It's one of the world's most thoughtful, original and influential contemporary collaborative architectural practices, which has received over 100 national and international awards for their projects throughout Europe and the UK. Ayhan is a Royal Academician and elected member of the Akademie der Künste. He is Honorary Visiting Professor of Architecture, Liverpool University, Fellow of the Society of Facade Engineering. He has chaired many international juries, including RIBA Sterling Prize, the RIAS Dulin Award, Berlin Art Prize, Czech Architecture Grand Prix Jury, and the French government's Nouveau Jeune Album. He was a founder director of Rice Francis Ritchie, a design engineering practice based in Paris. He continues to lecture globally, has written several books, including poetry, and his art is held in several international galleries and museums. Now the CV in Turkish. Şimdi Türkçe olarak özgeçmişini iletiyorum. Ayhan Ritchie, dünyanın en özenli, özgün ve etkileyici, katılımcı mimari tasarım ofislerinden birinin yöneticisidir. Ve bu ofiste ürettikleri projelerle Avrupa ve Birleşik Krallık'ta 100'ün üzerinde ödül almıştır. Ayhan Ritchie bir kraliyet akademisyeni ve Akademie der Künste'nin seçilmiş bir üyesidir. Kendisi Liverpool Üniversitesi Mimarlık Fakültesi'nde onursal profesördür. Ayrıca Cephe Mühendisliği Derneği üyesidir. RIBA Sterling Ödülü, RIAS Dulin Ödülü, Berlin Sanat Ödülü, Çek Mimarlık Büyük Ödülü ve Fransız Devleti'nin verdiği Nouveau Jeune Album dahil olmak üzere birçok uluslararası jüriye başkanlık etmiştir. Ayhan Ritchie aynı zamanda Paris merkezli bir tasarım mühendisliği firması olan Rice Francis Ritchie'nin kurucu direktörüdür. Dünya çapında ders vermeye devam etmektedir. Şiir kitabı da dahil olmak üzere birçok kitap yazmıştır ve eserleri birçok uluslararası galeri ve müzede sergilenmektedir. Kendisi bu gece bize Işık Mimarın Rüyası, Gölge ise Biçimi başlıklı bir konferans verecek. Tonight, Mr. Ayhan Ritchie is going to give a lecture entitled Light is the Dream of the Architect and Shadow its Form. Now the floor is yours, Mr. Ritchie. Thank you for accepting our invitation to give a lecture to our students and colleagues. The floor is yours.
Thank you. Thank you very much, but I'm not sure where my slides are. So
just 1 second, please.
Yep. I think okay. Thank you very much. İyi akşamlar. I'm not sure if that's correct for good evening, but it sounds very good. This is my hand, and it's somehow got dipped in paint. And I put this up simply to make a statement that I don't think color is taught at universities, schools of architecture very much anymore. And yet it's such a fundamental aspect of our understanding of the world around us and the world of light. What is light? Well, light doesn't exist without shade because we don't recognize it otherwise. But it's also energy. So in many ways we are back to the sun, the very origins of our being on this planet. And whilst we're on this planet, there is also the dynamic behavior of everything that comes along. Way that was going across a bridge with a flat tire. So from the sun, we get everything. and we get conviviality, communion with other people comes through light. This is the migration of people towards the sun at Tate Modern, which was by Olaf Eliasson back in 2003. And the behavior of people faced with the sun is quite remarkable, but it's in our DNA, and why civilizations around the world have constructed such magnificent edifices to the sun and the sunrise. At the other level, light in itself is a fascinating subject. Back in 1985, working with François Bastien and Jean-Louis L'Hermite, we looked at the idea of creating three-dimensional light. Historically, two dimensions, lasers, have been around for maybe 30, 40 years. And lasers now dominate the technology of our world, along with fiber optics. So people ask me, why would you want to make three-dimensional forms? And you can see in the three tubes on the right, some bird forms and some rings. And we were able to move them up and down in more or less in a vacuum. I don't know why we did it. It was just looking at the idea of three-dimensional light and making forms from it. I was also reminded of The Dark Side of the Moon by the Pink Floyd, and the possibility of taking light balls round to the other side of the moon and growing tomatoes, maybe. And power. So the power game, transmitting this energy that we've got from the sun, which is formed in different ways. These pylons represented something to do with the perception of color in the sky or against the earth. And the flight path where these particular pylons were located is where the Mirage, the French Mirage jets fly down the Rhone. And normally at the top of these pylons you would have red and white. But equally yellow is very, very visible against the ground. So we go back to shadow, emptiness. We often think of Malevich's Black Square as one of the great pieces of art of the 20th century. But 400 years before, well 300 years before Malevich, Robert Flood produced this etching, which he entitled So Into Infinity. And it shows that depth of the unknown, which actually drives most of our work. We tend to explore through light and through shade and darkness every single aspect of our lives. So I'm in the process now of writing a book, probably a combination of poems and aphorisms on light, and this is one of them. Shadows are holes in light, and light are holes in shadows. So why is it the dream of the architect? This word up here says opium, but it means dream. And we can go to The Little Prince, which I know is published and read in Turkey as much as anywhere else in the world. And we have the Lamplighter. And what's he doing? Well, he's lighting the lamp, the street lamp, on this very, very tiny planet. But because the planet is spinning, it means that he has to light the lamp very, very often. In fact, he doesn't stop lighting it. He lights it, it goes out, he lights it. And he has 1,440 sunsets every day. So the lamplighter, he's a cool customer, he's cool. But he's also busy. Does that remind you of anyone? Because that is the tragedy. It's like us. The lamplighter is faithful but unhappy. And he's miserable because his job doesn't allow him any rest, a bit like an architect. So before the lamplighters came, the image there is of the Earth, planet Earth, before 1800. And that's the Earth today, 200 years later. And we are all the lamplighters. We're all so very busy lighting lamps and working so hard that we actually don't know what we're doing. We don't see the world as we possibly could do. Some artists have made us look again, and obviously looking out towards the sky, and James Terrell is one example where he looks with his work to find the edge of perception, the way our eyes see. And that fascinates me a lot because it also relates to how our brains work and how we can be messed about with by our brains. The brain can make us actually perform as idiots, as very stupid people. And that's in the DNA of our brain, the biology of our brains. So why do we like the sky? You've got the moon. Why do you want to compete with the moon and the stars? My office is near Canary Wharf, and all the buildings have big signs, illuminated signs on the top. So this is quite rare to see the moon so clearly near our office. And if you go to Shanghai, you can't even see the architecture. You might as well have covered all of those buildings with adverts. So going back to what is light, well, light actually makes us wake up. And one particular wavelength is 480 nanometers. And this 480 nanometers is in the blue wavelength, and it triggers a chemical reaction at the back of our eyes to start our biological rhythm for the day. And one of the other interesting things about the eye is that black and white is not read by the rods and cones in our eye. It's read by ganglion receptors behind them. That was only discovered 15 years ago. But what about nature? Now I know Ulrika Brandy of Licht is listening from Hamburg to this talk. And I know she's been working in France in the summer trying to create biological light or biologically lit pathways through bioluminescence. And this is an area of research that could be very important in the future. And you can see the potential all at low level. But how much light do we actually need to see and work by? This particular work back in 1992 was at Ingolstadt in Germany, and it was a light festival. And Inge Maisch invited me and my firm to present something. So we presented the idea of graffiti by writing with light. So this is nearly 30 years ago. So you coat glass, in this case glass, it could have been plywood, but you use a torch and you write, and that image will stay for maybe 20 minutes. So you can overlay it. So this idea of graffiti and being able to influence the nature of light in a room did appeal to us. And when Kubrick made the film 2001, he also went back to the senses. And you can see bottom left, the astronaut with his finger pointing to the obelisk, this monolith, black monolith that you can see. Why is he touching it? Because he's got a glove on, it's full of electronics. What's it going to tell him? He's trying to replicate effectively what the people on the right are doing by simply touching something, because you feel texture, temperature, perhaps even other things, the kind of density of material and the way it can give under pressure. A sundial. Most sundials tell the time on the ring. That's the ring bit here. By taking the gnomon, this is the stick that goes up here, through the ring, and taking the ring over the top of the gnomon, you now have the shadow not only on the ring but also on the gnomon, so you can tell the time on the stick. By leaving the gnomon at the bottom, the ring at the bottom empty, enables children to come along and construct their own sundial by putting stickers on it. The history of architecture could be described as the way we let light into buildings. Initially, there were small holes in walls, Then a bit later in domes, they made a hole in the dome. And then we decided to start putting glass or material into those openings to keep out the cold and the rain and the wind. And this story is a true one. And we can follow it here with Sinan, and we can follow it basically through all of architecture around the world. This natural evolution of trying to bring in light in very mystical and beautiful ways. And of course, in the mosque, you get these wonderful rings of candles. Now they are light bulbs, since electricity came. But what was interesting when they were first used as candles, there are thousands of candles and they're all burning and putting up smoke. And the smoke rises. And Sinan was very clever because he actually draped wet cloths in the voids on the sides of the domes and collected the soot that was falling back down. And from those cloths they were wrung out and produced the ink for the scribes to write with. That's a nice little subtle use of the transition from light to energy to writing. And slowly but surely, both in Eurasia as well as in Europe, more and more glass was added and less structure was seemed to be holding up buildings. To the extent that you got the most beautiful forms starting to happen. And if one takes Gaudi's Sagrada Familia in Barcelona, what is equally fascinating but not evident is that the darker columns carry more load than the lighter ones. And the three stones that he did use for the columns all have designed loading capacities. So when we were doing a monument in Dublin, the first idea was in fact to scratch the sky, to kind of tickle it like acupuncture, and to bring the light down, but not in a bright way. Like you see on Ando's church, there's a very, very bright contrast to the shadow. Whereas the spire of Dublin, by shot peening, by bombarding the surface of the stainless steel, we were able to transition, if you like, the brightness of the light from the sky to the ground. And in that history of architecture and light entering buildings, obviously for me in 1850, so it's 170 years ago, the Crystal Palace more or less took most of the structure away. I was once accused by a well-known architect of destroying architecture with the work that we did at La Villette, when we made glass structural, because we took away shadows. Well, you don't take away shadows. Shadows are there all the time. I'm going to take a short break from talking now, I hope.
Bir dakika ara veriyoruz sayın izleyiciler. Birazdan tekrar bağlanacağız.
Okay.
Yeah, I've told. By the way, we cannot see you. Can you please put on your webcam?
I had it on earlier, but okay.
I have been writing, but you have to start sharing.
I apologize for this. Not quite sure what's going on.
Oh, no problem.
Show the movie. Can we show the movie?
Yes.
It's not important to see me. It's true. Is that my webcam? I think that's what they want, isn't it? So, should I click it? Hmm? We'll leave it for a minute. I haven't got a clue of the sequence. Normally we have it. Normally I have to flip. That was the 20th anniversary film of that building being built, and it's cleaned by robots. But what was also nice is it started in Aachen, and you may have seen the picture next to the Sinan Mosque of Aachen Cathedral with its apse, largely coloured glass. And it's just a nice story that the Leipzig project for us started there with the young office of GMP and finished up in Leipzig with what is a remarkable building. What all this leads up to is the nature of the architecture that we're trying to put on the planet, if you like, for the benefit of the people that we work for, which is the public. It's that commitment to deliver better environments and better buildings to the public. And for me, it comes down to light and beauty. And the definition of beauty, I have a very simple one. It's non-linear behavior. It's the beauty that one sees when leaves change color, the way that snow falls, or the way that light dances on the air and the sea. So in all of our architecture, although it's not necessarily that evident, is this non-linearity. And you will all recognize it in these pictures here. For this particular film, I'm grateful to Ulrika Brandi, just showing how shadows form the light. And also although predictable, you wouldn't waste your computing power to predict the amplitude and the wavelengths of those rings of light. So we missed one film. Okay. This is the project that transformed glazing worldwide, which we did in early 1980s, so it's 40 years ago. And you'll be familiar with the kind of bits and pieces that make up how the glass is held. But fundamentally, you can also see on the picture on the right how glass is opaque, depending on what angle you look at it, and can be transparent when you're perpendicular to it. But the secret behind this structure is in fact the nonlinear behavior of the structure behind the glass. The glass is the stiff plane, and the structure itself actually deforms a bit like an elastic band, but it restores itself to its initial geometry. But that non-linearity was the first time, or nonlinear behavior, that we managed to do it in solid state materials. And at the same project at La Villette, we also developed robots, or robotic mirrors, held within domes that rotated. And those mirrors could be angled and programmed to follow the sun, to focus the sun, or to bring in parallel light, and in fact also to orientate itself to the full moon. The work at La Villette led us to the Louvre, where I.M. Pei was the chosen architect, and he wanted to put in a transparent pyramid in the main courtyard, which you can see bottom left. Very well-known building these days. But what he never quite understood is that when you're outside looking at an inclined surface, which I tried to show you just now with the opaque surface at La Villette, is that you will never have a transparent pyramid during the daytime. It'll always have a very high reflection of the sky. At night, of course, it changes, when the light inside is brighter than the light outside. On the right is the most touched space probably in Paris, which is the space between the point of the inverted pyramid and the stone pyramid underneath to stop people banging their heads. But the edges of that inverted pyramid are polished glass, and they were designed specifically to create these rain rods, these rainbows of light. And when we were also working at the Louvre, we developed the enclosures for the new sculpture courts. And I went to the research at the Arts et Métiers Library in Paris and came across this man called Jean-Baptiste Laurent d'Alembert. And d'Alembert co-wrote the first encyclopedia in the Western world, the Universal Encyclopedia with Diderot. Very few people know about d'Alembert. He was the mathematician, the scientist, and he wrote all of the scientific and mathematical aspects of that encyclopedia. He also had a brilliant way of understanding, if you like, the idea of even a library. You only need 3 sections: memory, reason, and imagination. He also did a very small paper explaining how you can avoid having a sharp shadow or having a sharp shadow on a surface by the size of an object relative to that surface. So if you pick up your pen and put it between the light source and your desk, you can actually move it up and down and you'll see the shadows sharpen and also create penumbras or shadows. And that was quite important to design the sculpture courts so that sharp shadows would not lie on the sculptures below. And the initial design is the one on the right, which shows with the red lines and the blue lines an imaginary movement of the sun relative to the main structural ring, which is, from D'Alembert's calculations, would give us a 150 millimeter diameter tube. So that's what we designed for, and we developed a fixing system not dissimilar to the one that we had done at La Villette. The consequence, however, was that I.M. Pei didn't quite understand or believe that this would work, even though we were finishing off La Villette. And also, he had overspent some money somewhere, so we had to compromise and redesign it with the one on the left. And as you can see, a continuous aluminium extrusion plus the structural tube, suddenly you have a big broad shadow line being created. And so we didn't actually achieve what we set out to do. And you can see on the far wall on the picture on the right, the quite sharp shadows coming through. Those shouldn't have been there. And you can also see another reason why it costs some more money is because top left, there are sunshades across all of the roof of the Louvre courtyard. And those are 25 millimeter diameter tubes, which have a slot in them filled with foam. And they are the means of absorbing the sound energy in the space. The consequence of which is it's fine if it was a flat surface or relatively flat surface, but with the kind of arched vault, at certain times of the day, one side goes very, very dark whilst the other is bright. And that's to do with the angle of the sun coming into the space. So light has evolved, and in the 19th century, there was a man who actually melted some glass and fired it from a bow and arrow on the end of an arrow, and it created a trail of fibers. And that was in about 1880, and that was the beginning of fiber optics. So the combination of lasers and fiber optics, maybe glass, underpin our entire society today, the global society. But what is also interesting is you can simply pour some water from a tap and shine a torch into it, and the water will conduct the light, providing the water carries on flowing. And another project, also back in the last century, was the idea that you could have an eternal painting where anybody who has access to a computer can create their own hieroglyph. Here it's showing a 20 pixel hieroglyph, and you join this global painting. This was a monument to communications that the French were going to give to the Japanese. And unfortunately, the Japanese wanted to buy my colleague, Olivier Aubert, who developed the software, wanted to buy his patent, and they wanted to pay for everything. So the president of France stopped the project because the Japanese at that time didn't understand how to receive a present. So that's light being conducted down water. Simple. So water is fundamentally an optic conductor of light. Get out of here. See? Shadows. More shadows. But this is now obviously using material which changes over time, and that's again a quality of non-linearity. And at the turn of the millennium, we won a competition in Milan, a light monument, which was the basis of the competition. And this one also conducts light. And the design of it was that we had, in fact, a non-centered matrix of fiber optics. And it was basically a statement that the global evolution of communications was one where there was nobody in control of the information anymore. Well, we may have learned that certain things like Facebook and others might have some control of that information and not you. So one of the things that needs to be done today is for some people, smart people out there, to rewrite the algorithms so that the information that you are delivering remains yours and not belonging to Facebook or Instagram or whoever. This monument was up for 18 months, and then the Milan authorities, through the Ministry of Culture of Italy, decided to take it away. Apparently without permission, because in Italy, once you do something that's sculptural, as an artist, you have rights. It didn't seem to make any difference to the authorities. In the same year, we also won a competition for the monument in Dublin, which I mentioned briefly earlier. And you can see here again, this whole art of creating things with a knowledge about light and shadow that enables one to do things that are slightly stupefying and surprising for people. Good man. People close up to this monument in the mirror parts actually use it to, particularly the women, to make up and put on their lipstick. So it's a moment of encounter, genuine encounter. Do we get a chance to change the slide? Yeah. Go on, Emma. I won't dwell too long, but one of the things was that because the spire is so tall and so slender, it turns out that the Irish police force in Dublin has one helicopter, and so we had to have a light at the top of 2000 candela, 2000 lux, and because the spire moves, it changes the angle. And so for the pilot, there's a rule about a 3-degree horizon above or below the plane. And it also, at that time, nobody made an LED of 2000 candela. So that research happened in Los Angeles between Hewlett-Packard and Philips until there was an answer. And so there are 11,000 holes at the top, which is the candle for Dublin, and the very high level of lighting at the very top. And because of the bombardment of stainless steel on the surface of the stainless steel of the spire itself becomes blacker than the sky, which you can see on the right. And that enables, to some extent, to have a proper conversation with the moon. And you can also buy the candles. They're very good for Christmas. But the other thing, even in a very simple project like a train station or an underground station, we just observed there was a tree nearby. And so we exploited that on the side elevation, so that building, and even on the front, the setting sun coming from the west through that tree would actually perform the picture on the building rather than some advert. And also with Ulrika Brandy at another level, the sun and the moon came into play in this task light that we designed together. And on the control buttons, bottom right, there's a half circle with a black half disc, which is the moon. and a full one, which is the sun. So you have two color temperatures. So in the early morning when you wake up, you can actually put on the bright, colder light. And as the sun sets, you can bring in the warmer lights and reduce it even down to 1 lux, like a candle. And another one that we've been doing together with Castaldi in Italy is a light that is an uplighter that distributes the light evenly without hot spots, which is what you normally get. This one is up only because of the birds. This is a phosphor bronze cladding, but because there are seabirds flying around a lot, they shit, and they pass by, and the shit lands on the copper bronze, and it reacts with the copper and creates colors. So it's like an everlasting painting again. And that again is the non-linearity, allowing nature to change your building. In the same way that this one, which introduced gabion back in 1995 to architecture, allows plants, animals, all sorts to be inhabitants of the architecture itself. This is a more recent project which combines two different things. One is the redness and the warmth of the internal room of the theatre, and above it, sitting on the roof, is a daylit recital hall. So one has cherry wood and the other one has white lime-washed oak. Which brings us to another idea of when you get a dark street, and here it's full of plane trees, rather large, making the street very dark, the building itself can become the light source. So in the daytime, it's a white building, but at night you don't look up and see lots of light fittings through dark windows. So the building actually has this whiteness both in the daytime and at night time. And by the treatment of the surface of the cast glass externally, you get rather wonderful light forms, and internally you get a soft glow of light, which is the picture on the left. This is a neuroscience research building, and the projected image on the end is of a neuron firing. But here you can see the softness of light, so you don't get glare created from this building at all. And on the side of the building that you can't see is a wall that moves with the wind. Again, it's random, it's nature influencing, whereas the front of the building has two wavelengths in the curves of the facade. So you're trying to talk against the wind, sorry about that. Whereas the front of the building has this two wavelengths and two amplitudes. But that's a kind of static and with a slightly humorous commentary on the fact that the people working inside are, so many of them, autistic, extremely bright people. But I found that the theoretical computational neuroscientists were a little bit further advanced in their brain power than the experimentalists. But that was a sense of humor that I had. I'm very aware that it's now 45 minutes, so we run this film. So the building itself has become almost an animation at night of the brain itself, with its various circuits running around and misbehaving. Oh no, go back one, please. Okay, go forward one. Go forward one. There's a little film coming up of simply water flowing, which I took in Esfahan, no, not in Esfahan, in Kashan at the Paradise Garden a couple of years ago. Go to the next film. Oh, we've missed it. Okay. Oh, sorry, it's afterwards. Yeah, you can run this one. That's fine. What's nice about this is that the picture of the trees appears still as the leaves float past. It's quite an illusion. Next one. Yeah. This is the one from Kashan. And in slow motion, the beauty of non-linearity really is fantastic. And if architecture could be like this, I'd be a very happy man. So I'm hoping you're getting the idea of what non-linearity is and why we can all appreciate it and have a common sense of the beauty. So there you have water conducting light and energy, which fundamentally, those two elements, water and energy, are the two issues facing our global planet today as a major problem. And it ends up looking like Darth Vader. Is that the end? No, not quite. Nearly at the end. No video feed. Start a conversation. Okay. Emra's in control. Emra, can we just finish the talk?
Yeah, we can.
Two more slides.
Yeah.
Quite important. Just 2 minutes. 2 more slides, I think, or 3. Not many. Don't need that one. We've had that one. That's not. It's a still. Yeah. Yeah. So, out of these experiences of designing and making architecture with colleagues of all sorts, the point of which I've come to is we're designing with the mind in mind. And a lot of our research now is at the neurological level to try and understand how we can design better environments in our world. So using nature's own laser, the sun, to sculpt space, understanding that the earth is simply a natural greenhouse of our basically of our house, the earth, and reading the history of architecture as the way light enters buildings. That combination. So light is also our umbrella against the dark sky and falls like rain from a cloudless sky. Thank you very much. I owe this quote to Ulrika Brandy. Thank you. Now what?
Okay. Thank you for this wonderful lecture. It was really very inspiring for all of us with the films and with the slides. It was a very emotional and spiritual way of looking architecture, I think. Now we have the questions and answers section, and it's, as you know, it's always difficult to start with the first question. So I am going to ask you the first question and making some remarks, if you if I might. I will start my comment with Louis Kahn. As you know, Louis Kahn is known as the master of light. He designs his buildings, shaping them by light and shadow. Actually, Kahn believes that architecture began with the making of a room and believes that a room is not a room without natural light. And he, in his buildings, he tried to bring his interiors to light in the most imaginative ways, using light in very, very different forms. But he also talked about shadow because he was talking of shadow as a form giver for silent spaces. And I want to quote one sentence by Kahn. He said, even a room which must be dark needs at least a crack of light to know how dark it is. So my question is for you: have you? I'm sure that you have read about Khan, and I would like to hear your remarks about his influence, maybe, on your projects and the way you approach light and shadow.
But I think it's true that one of the most sublime pieces of architecture that I've ever been in is the Gimbal Museum in Houston.
Yes.
And here, in a sense, is just concrete, marble and light. And I think he understood the simplicity in the nature of form, light and shadow in a remarkable way. But what I also know, well, I don't know, I'd like to know, did he ever design a theatre, the inside of a theatre where you don't have natural light? And how would he have done that? Because I think what we tried to do with Enrico Brandi at the Royal Academy of Music was to introduce the idea of a candle, hence that last slide of one light in the wall, half a light buried in the wall, because theatres only functioned with candlelight when they first started indoors. And so recapturing that spirit of the candlelight as against the artificial light seemed an important thing about notions of emotion and warmth to do with theatre inside. But I have to subscribe totally to Louis Kahn's view on a number of issues to do with light and shadow. But also one other one, which I never forgot of Louis Kahn, is he described you never have a corridor in a building. If you make a corridor in a building, you don't have a room, you don't have a space. It's not, a corridor is not made for human beings.
Well, servant spaces, he describes this theory like that. Now, I would like to read one question that has been expressed here. Suzan Tanlı says, I'm a part-time lecturer in architecture at our university. She's a lecturer. I would like to thank you for this inspiring presentation. I have been giving you a commemorative bridge project as a reference in my studios in the introductory lectures. So simple, so elegant, and yet so rich, so inclusive. Technology, poetry, accessibility, aesthetics, contextual response, sustainability, all of these melt in each other and create this elegant design. A great example to read and understand what exists beyond the scene in architecture. So this is a comment, actually.
It's a very nice comment. I think, I mean, what she's getting across, I think, is the fact that in a way you get so much knowledge over many years that you can, it's not melting them into each other, but you meld them into each other so that you cannot.
Oops. Dinleyicilere kısa bir duyuru yapmak istiyorum. Kendisine ulaşmaya çalışıyoruz şu anda. Sesi gelmediği için umarım tekrar bağlantı kurabiliriz. Biraz sabrınızı rica ediyoruz. We
Hello,
are
hello.
almost, yeah,
And,
we can
we
hear
can-
you now.
and we should be able to see us soon as well, hopefully.
Yeah, I think we will see you too.
Apologies for the...
Maybe, no, it's okay. Everybody is waiting because everybody is writing how influential your speech was. So I think I will go on, not to take too much of your time while Alex is helping you for your so that we can see you. But one of the
Yeah.
questions is, let's see, Ulrike Brandi has asked, what are your favorite light phenomena in nature?
Sun rays.
Sunrise.
Sun rays or sunrise, yes. Or sunset.
Yeah. Oh.
Yeah.
Okay, or sunset. Okay, a professor from our university asks, he first made a comment saying light can be considered as a material, as also Stephen Hall says, and very important, inspiring concept in design. And your conference was great in connecting design and light, even a solid wall reflecting shades of trees. Wonder also about your Bratislava project.
Mm-hmm. I think I don't know about Stephen Hall, but I've always written since probably 1980 that light is the first material of architectural thought. It's also the first material of architecture. It's impossible for me to conceive of any space without thinking about light first. And that's why working with lighting designers. I've also written, I think, in Ulrika Brandy's light book, in the introduction for her, that I find it difficult to work with lighting designers that think about light through artificial light or through fittings or fixtures. I'm more interested in the lighting designer who understands that you only really need to work with natural light until the light fades completely, at which point you have to ask yourself, what are you doing in the space that needs artificial light? And that maybe is when the artificial lighting designer comes into play. And I think it just goes back, 200 years before electrical light, we used candles. Candles flickered in the wind. And this is why if you want to propose to your lover to spend life together, you would never do it under a fluorescent tube. Because the fluorescent tube, you can't read the flickering. Whereas you do it across a table with a candle, the candle is already dancing in the eyes of the person that you're proposing to.
Okay, there's another question. Sir, it's really admiring how the facades are so dynamic and fluid, like reflecting actions inside of the building. It reminds me the motion in cities. Is this a goal that you set for your designs, or is there any different motivation about it?
The motivation is the one I was trying to explain about non-linearity, that you want the viewer to feel that if they're looking at the building for any length of time, that it's not the same every second, it's changing. So they become very conscious of the way that light is moving and playing on the surface, which tells you immediately, actually, I'm on a planet that's turning around a sun, and I'm turning on myself, which of course you don't normally feel. And so I think architecture can become more, if you like, biospheric in itself, to relate to nature and the cycles of light. And that brings you back to being someone on a planet that's alive with huge, I don't know, emotion and forms of life. And we tend to forget that.
Okay. There's a question about films. Elif Temiz has asked, are there any films that you can recommend to architecture students that you think the light, shadow, and the architecture or the space are given together well, or inspired you and your design?
I can't think, but I can recommend some films. I would go to black and white films to start with, and I would go to On the Waterfront, which I think featured Marlon Brando because it's incredibly atmospheric. It's also politically powerful and socialist. And I think some of the films by Eisenstein as well, the Russian filmmaker, Metropolis is a great, Metropolis is a good film to see.
Yes.
And if you want to read about the disasters of urbanism after the war, you watch Kubrick's Clockwork Orange.
Okay, and now let me see. It was very informative, says Güzide. Enlightening, actually. I like the idea of buildings as living things, constantly changing in reaction with the environment. Yeah, this is a good comment. And then the question is, in creating such sensory effects, which materials do you use? For example, in Alba di Milano or the exteriors of Sainsbury Welcome Center. So the question is, what materials have you used?
Well, in the Alba di Milano, we wove together fiber optics and stainless steel wire. The fiber optics were randomly fractured when they were put onto the spool in Japan. So you got a sort of almost like 2 tons of fiber optic cable came over. In each fiber, each sleeve has about 40 fiber optics in, and you can randomly fracture them, which allows the light to escape. The stainless steel wire was to give a stiffness. Not the easiest thing to weave together on a loom, because the fiber optic is the warp, which is the length, down the lengthway of the cloth, and the stainless steel was the weft. And of course they have different tensile qualities. So keeping the fiber optics tensioned enough was quite tricky. The Sainsbury Welcome Centre, interestingly, is ribbed. It's a bit like a microscopic profile, sinusoidal profile, which you can run your nails across and you'll make a sound. You could almost play tunes on the facade, as well as watch the different behavior of light. But in order to kind of keep the simplicity and the waves going, the waves go down to this microscopic level. And also at that level is where all the water runs down, the rainwater off the facade. So it always looks clean, because the dirt on the crest goes into the valley and the rainwater brings the dirt out. So these are things which do with the tactile qualities as well as the visual qualities and the sound qualities of the material. So we do look at materials in buildings. Again, this is designing with a mind in mind, where you're aware of within your body of all the senses that can react to things. And if you would like to know more about that, the latest edition of Architectural Design, the journal, I've guest edited, and it's called Neural Architecture. It's the current edition. And you'll read a lot more things there, and actually may get some inspiration about how to think differently about architecture.
And Selahattin Tüysüz has asked a question. He says, hi, Ian. Thanks again for this amazing talk. My question is about your opinion on the observation and application of light on urban scale rather than buildings. We worked with Ulrike on Haliç and Kadıköy urban planning competitions. It was really efficient and she gave us amazing feedback. But I guess it would be nice to hear your approach on urban lighting philosophy as well.
Okay, we'll start with the presumption that I presume the questioner is asking about the night lighting, because I would look at the urban form to sculpt the urban form with the sun, because most of the time you spend, I don't know actually anymore, maybe we spend more time indoors with artificial light than we spend outdoors in the daylight. But the two forms, if you like, one is the urban form in daylight and sunlight and shadows, and the other form of the urban environment is at night, where you have cars and vehicles overtaking all other aspects of artificial lighting very often. And you can see in late developments in terms of artificial lighting that people are beginning to design lamps for the urban environment which illuminate the road and not the pavement where people are, which is daft because cars can illuminate themselves in terms of driving, but also are introducing lamps which collect information about people, their behavior, as well as introduce the idea of cold light and warm light, so that the urban lighting can actually respond to, if you like, the rhythm of the day and night properly. So there are evolutions, but a lot of it's about information technology tucked into street lamps. But fundamentally, and it's a problem particularly in the United Kingdom, street lighting is measured by the light coming off the surface of a road, and you have to meet certain standards. And that has no sense whatsoever, because, as I said just now, vehicles have lights, they can see. So do you need bright lights, really bright lights in the city? I don't think so. And I recall, in fact, Ulrike saying, I must be 10, 20 years ago, Berlin, and perhaps many other cities now, have reduced the level of artificial lighting in the city, street lamps, because you just don't need it. And then they stay very safe, but at least you begin to see, if you like, the world differently instead of it being blasted at you. I don't know, I hope that answers the question.
Yeah, I think it does. Ulrike Brandy is typing, but she didn't finish her question.
Well, she can ask me later. She can ask me later.
Well, I think her question will be the last one we'll receive. Just let's wait for a minute. Maybe she'll finish her question. I can see she's writing, but maybe she quit. Well,
She's still,
okay, I think.
Anyway.
Maybe she'll ask you later on, because I cannot, I think she quit writing. Oh, she's still writing. She's still typing.
But I think the
So I think there were good questions. I think the students asked you about films and books and made very wonderful comments. Some of these, she already wrote this question. Do you think the actual pandemic changes our social life? Which impact does this have on architecture, urban and light?
that's another lecture.
Well, this is a promise for the near future.
Well, I think, I think it's not the last pandemic we're going to get probably in the lifetime of the students. I think I can't remember. Anyway, that's another story. But I think so. The question of social distance raises fundamental questions about how you, as human beings, socialize, because we are social animals. Fundamentally, we rely on our emotions and our embodied feelings. And if things like touch, like doing this lecture, I can't see any of the students, I can't read anybody's eyes. And that's a visual world. That's a visual world which you think the screen and IT can cover, but it doesn't completely. And you have no sense of smell of the room. You have no touch. And so you're disembodied in a world where you are functioning as the students are at the moment in their learning environment by being not together. So what I think people might think about is how much information do you need visually to transmit versus sound and the quality of sound? And is there any other ways we can bring any of the other senses into play in a much stronger way?
Yes. Well, one of the people I want to invite is Plasma. Maybe he's going to talk about all these different senses, and so the importance that we need to give to all of these different senses. Well, there is a proposal by Veysi Tosun. He says, we receive what you said as a promise for the next semester, and they even suggested the title, Sun, Light, Pandemic.
Very, very good. And Johanni Plasma is a very good friend, and I think together we've been working on the emotional aspects of the human being for maybe 2 or 3 decades now. But we tend to kind of collide maybe once or twice a year in exchanging ideas about it. So he's a very beautiful talker as well. He has a very nice way of explaining things.
Yeah, yes. Okay, so we'll keep in touch, and I think everybody is influenced. We don't want to leave you, but I know you have another meeting afterwards. So,
well, may I just say thank you for all the students and others who have actually spent the last hour and a half with me, because it's always a privilege and an honor to have people listen to what you have to say. And I hope that they've managed to take away one new thing from this talk. Would be lovely to know.
I think we have all learned a lot during this lecture, not one, but many things. So thank you very much in the name of all the students and academicians and architects who have been listening to you. Everybody is thanking now and saying goodbye.
Thank you.
So take care and stay healthy. And thank you, Alexandra, for helping us through this whole process. Thank you, Ayan.
Thank you very much indeed. Thank you.
Thank you.
Bye-bye.
Bye.